So page 347, 27. Okay, is that this chapter? Okay, even though that's a great question, I'm going to skip that one just because it's not something that, that was something we kind of did on a different day. But determining the zeros is a good one, so let's do that one instead. So it's page 3, it's actually on page 348, and it's number 39. All right, we've got g of x is equal to x to the 4th plus 3x squared minus 4, and it wants you to find all the zeros. So I know I need to find 4 of them, right? And so I'm just going to start trying some. If I plug in a 1, I got to fill in missing zeros. There's a missing x cubed. There's a missing x. All right. Oh, why am I drawing sideways? Come on. All right, bring down the 1. 1 times 1 is 1, plus 0 is 1. That's a 1 and a 4 and a 4 and a 4 and a 4. Did I do 1? 4 times 1 is 4. Yes, 0. Yep. And you get a 0. Okay, yay. So 1 is definitely a 0. So 1 is a 0. And then now what I'm going to use is this depressed equation, which is an x cubed, so I can't factor it yet. But I'm going to use those as my coefficients now. 1, 1, 4, and 4. And I'm going to try negative 1. Bring down the 1, and then negative 1, 0, 0, 4, negative. Oh, nice. All right, so that means negative 1 is also a 0. And then what you do is use this depressed equation, right? This guy right here is x squared plus 4. And you set it equal to 0 and solve for that. You'll have an x squared equals negative 4, which means x is equal to plus or minus 2i. And so your zeros are, we got 1, we've got negative 1, 2i, and negative 2i. That's 4 of them, so that's all of them. All right, page 353, 17, 18. Two different polynomials with real coefficients have the same set of zeros. How is it possible? So a couple different ways. You could have, so this is page 353. Well, it actually ended up being on 354. They want to know two different polynomial functions with real coefficients have the same set of zeros. How is this possible? Well, this guy, I'm just going to make up numbers. X minus 1 and x plus 2, and let's go with x minus 3, right? This has zeros, at 1 and -2 and +3. Well, this guy, let's throw a -2 in front. That was a coefficient. That -2 does not affect the zeros, and so you still have the same zeros here. You also could have put multiplicities on here. Could have been cubed and x plus 2 to the 4th, I don't know, and x minus 3 squared. They still have the same zeros, they just have multiplicities on those zeros. So that's how that's possible. How are these graphs alike and how are they similar? Well, the only thing that they're alike is that they have the same zeros, but like so they number 18. They have the same zeros, which means that the graph touches, so that means the graph touches or crosses. I'm just going to say touches, touches, or it could cross over the x-axis in the same spots. I should say at the same x values, right? But the first one's a cubic that's opening, like it probably does something like that. The second one is also a cubic, but it's going to be flipped the other way, like that, because of the negative in front, so the left-hand side will go up. This last one is a 7 to the 9th power, so it means that it's going to like flatten out here, come up, it'll flatten out, whoops, shoot, -2, let's go back. Things happen differently, so this is, okay, so -2 is first, so -2, it's going to flatten out and then come back down, and then at 1 it's going to flatten out, and then at 3 it's going to come down and touch and bounce back up and go back up this way. So that's the kind of things that'll happen. It's still crossing the x-axis at the exact same spots, but what's happening there at those zeros is different things are happening. Can you do this equation to find the asymptotes, intercepts, and graph? Okay. Maybe. Hopefully it works. You don't want to tell me where you got this problem. F of x equals x squared plus 2x minus 8 over x plus 2. And then you want me to find the asymptotes, the intercepts, and graph it. All right, so I would factor the top, which would be an x plus 4 and an x minus 2, like that. All right, so you're going to have a vertical asymptote at x equals -2. Your horizontal asymptote is going to be none because the degree on top is bigger than the one on the bottom. But then that means you have a slant asymptote at what? Well, you're going to divide. Divided by x plus 2, and you'll get an x, and then x squared plus 2x. Subtract it, and you end up with a -8 as a remainder, right? And so your slant asymptote, just ignore the remainder, right? X doesn't go into -8. Your slant asymptote is y equals whatever you get up there, whatever the quotient is. So y equals x is going to be your slant asymptote. Intercepts, well, x-intercept is when y equals 0. And so you'll plug a 0 into the y, or into the f of x. And what will happen is it's only the numerator that will contribute to y being 0. If you multiply both sides by the x plus 2, it goes away. And so you've got x is -4 and +2. So I've got x-intercepts at -4, 0, and then also at 2, 0. Y-intercepts is when x is 0. And so y would be, it's easier on this one to plug it into the original, because you'll have a 0 plus a 0 minus 8 over 0 plus 2, so you get a -4. All right, and then graphing it, we've got, okay, help me remember, y equals x, x equals -2. Boop, 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 boop. All right, so we've got x equals -2 is a vertical asymptote. That's ugly, but okay. We've got a slant asymptote going through y equals x. And again, that's ugly too. Whatever. What were the, let me go back. The intercepts were -4 and 2, and then -4. Okay. So we've got an x-intercept at -4, 0, and at 2, 0, and the y-intercept I think was -4. Hopefully I'm right on that. So we got those points. Remember I told you that if you get a slant asymptote, you're going to be in the opposite diagonal corners of this crisscross. So you'll either be in the inside, so you'll either be like in this guy and that guy, or you'll be over here and over here. And obviously with your intercepts, that's what tells you which sections they're in. And so I don't care about it being any more perfect than this, that just follow the asymptote and then go through the intercept. Don't cross over these asymptotes because you can't. They don't do it. They don't touch. But go through and go through and like that. All right, there we go. That was that one. Page 380, number 7. Graph the function f of x is x times x minus 2 squared times x plus 1. All right, so we have zeros at, when x is 0, that's coming from this x that's in front there. I have a 0 at 2, which has a multiplicity of 2, which means it's just going to touch the x-axis, but stay on the same side of the x-axis that it was, and then also at -1. So we got -1, 1, 2. Okay, so I have zeros at -1, at 0, and at +2. And then you have a positive leading coefficient. What is the degree of this polynomial? The degree of the polynomial is, we have an x to the power of 1. We have 1 plus 2 plus another 1, so it's a degree 4. Degree 4, which is even, means they're both going to be pointing up in the same direction or down, both pointing in the same direction. The positive leading coefficient tells me, all right, they're both pointing up. So that means this guy is going up like this and up like that. at 2, it's a multiplicity of 2, which means it's just tangent to the x-axis, and the fact that it was up above means this guy's going to go like that, right? But then the other ones have a multiplicity of just 1, so they're just going to cross over. So one example would just be something like that. I didn't mean to go all wavy on it, but something like that. You could have gone lower and higher on the little valley and mountain there, but other than that, that's what it would look like. All right, 16 and 17 from the quiz. So they want you to decompose 19x plus 3 over 3x squared plus 5x minus 2. All right, so what you want to do is factor this, which will be a 3x and an x, and we want a positive 6. That's what's going to work. So 3x squared plus 6x minus 2. Yep. Okay, so that's how that factors. So that means what you're going to do is set this equal to a over the first factor plus a b over the second factor. And then you'll multiply both sides of the equation by the least common denominator. So we've got 19x plus 3 would equal a times x plus 2 and then plus b times the 3x minus 1. And then you'll let x equal values that would zero out the other. So if I let x equal negative 2, you would have a what? Negative 38 plus 3 is equal to b times negative 6 minus 1 would be a negative 7. And so that's a negative 35 is equal to negative 7b. So b is equal to positive 5. And then I'm going to let x equal, we want b to zero out. So I need to let x be something not friendly at all, huh? Did I do that right? 3x. I think so. Tell me if you see a problem. My current on the chat. Yeah. Okay. So if I let x equal 1/3, yeah, then that'll zero that one out. Is it really this ugly? But yet it comes out nice. Must be. Okay. So we got 19/3 plus 3 will equal a times 1/3 plus 2. So what is that? That would be a 9 over 3. So a 28 over 3 equals a times 7/3. Oh, nice. All right. And then to undo that, you want to solve for a. The fastest way to get there is multiply both sides by 3 over 7. And then the 3's cancel, and 7 goes into 28 4 times. So even though it looked ugly, right, it turned out nice. You plug in the 4 into A, and you plug the 5 into B, and your answer is 4 over 3x minus 1, and then a plus 5 over x plus 2. There you go. All right, that was 16 on the quiz, 17 on the quiz. I'm going to attempt to draw this. We got zeros at negative 3, at negative 1, at 0, also at 2. And it flattens out there and goes that way. It did a little won't there. It crossed straight over there, and it flattened out here. I don't know, something like that is what it looked like. Okay. All right, so we've got zeros at -3, at -1, at 0, and at 2. And it said lowest degree, right? So when it flattens out, you just want to do a higher power than just a 1. And it's still crossing over, right? It's not just tangent. It's still crossing over, so it's an odd power, odd degree. But this one I'll say is a multiplicity of 3, because it says lowest degree. So you don't want to say multiplicity of 5, you know. At -1, it's just crossing straight over, so I would say that has just a multiplicity of 1. Or not, whatever. At 0, it's tangent there and bouncing back on the other side, so that means that it's an even multiplicity. To me, it didn't look like it flattened out, so I called it a multiplicity of 2. And then at x equals 2, it's odd because it crosses over, but it did flatten out, so I'm going to say that that's a multiplicity of 3. Now, the fact that our arrows in the ends are going in opposite direction means that we should have an odd degree for the total polynomial. So when I add up my multiplicities, 3 plus 1 is 4, plus 2 would be 6, plus 3 is 9, which is an odd degree. So that matches up. So I feel like I did that right. The other thing, though, is that your leading coefficient for an odd degreed polynomial, a positive leading coefficient would be right arm up, left arm down for positive. And when you have the left arm up and the right arm down, then this is a negative leading coefficient, right? And so definitely this guy is this one. And so putting that together, I would say I called it, my polynomial is p of x equals, and then I'm going to throw a negative in front there. It's typical to throw the x minus 0 first because it just ends up being x. So this is an x squared, and then an x plus 3 to the third power times an x minus -1, so plus 1 to the power of 1, so I don't need to write that, and then an x minus 2 to the third power. And that's, oops, how I wrote my answer. All right, that was 16 and 17. Number 12 from page 374. Gave you rad 2 times the square root of x plus 3 is equal to x minus 1. You could square both sides the way it is right now. But when you square the left-hand side, you got to remember to square this guy also. So what I did instead is they're both square roots, so you can multiply these guys together. And when you do, it's a single rad, and you just take the 2 and multiply inside, so it would be a 2x plus 6. That's what I did. You could have squared both sides. You'll end up with the same answer as long as you remember to square that rad 2 also. So now I'm going to square both sides. Left-hand side, you're just left with what's underneath the radical. Right-hand side will be an x squared minus 2x plus 1. You want to set this guy equal to 0, so you'll have an x squared minus 4x minus 5, which factors as x minus 5 and x plus 1. And so you get x is 5 and x is negative 1, and you need to check yourself before you wreck yourself. And so when x is 5, does it work? Rad 2 times the square root of 16, is that equal to 5 minus 1? And that would be, did I do that right? 5? Oh, square root of 8. I need to plug it into the original. And the original would be a 5 plus 3 would be 8. So this is a rad 16. Is that equal to 4? And yep, it is. And then when x is equal to negative 1, you'll have a rad 2 times the square root of negative 1 plus 3 would give you 2. Is that equal to negative 1 minus 1? Well, that's rad 4. Is it equal to negative 2? Well, no, because the square root of 4 is the principal square root, and that is positive, and so that is not equal to it. And so we cross that one out, and our answer is just 5. All right, I already did the last problem on the quiz because that was number 17. What else? What other questions do you have? Boop, 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 boop. Page 380, number 7. Didn't I just do that one? I think I did. Page 380, number 7. Didn't I? Or am I going crazy? Yeah. I did do 380, number 7. Number 13, though. All right. Number 13 is a new one, though. So page 381, number 13. So determine all of the all of the zeros of x to the 5th minus x to the 4th minus x cubed plus x squared minus 2x plus 2, given that p of I is a 0. All right, so if p of I is a 0, then that means I is one of your zeros. It also means that negative I will also be a 0. So you have two choices. You can use synthetic division. On the first one, it's going to be a little ugly, but on the second one, it'll be real pretty and nice. Or you can figure out what the quadratic is with those two zeros, with the I and the negative I, and then do long division. I don't know, which one would you prefer that I do? I think I would, let's see, the sum of them would be 0 and their product. It's not a bad long division. I know you're the one that asked for it. Would you rather see synthetic division to do it or long division? Okay. So I'm gonna plug in these two zeros that I know, right? I'm gonna plug in I into the synthetic division. My coefficients are 5, 4, 3, 2. I'm not missing any coefficients, so they are a 1 and then a negative 1 and then a negative 1 and then a positive 1 and then a negative 2 and then a positive 2. Bring down the 1, 1 times I is I. This is what I mean. This first step is going to be ugly, but the second time when we do the other 0, it'll be nice. That's a negative 1 plus I. Multiplying that, negative 1 plus I, I'm going to do it off to the side here, times I. You'll have a negative I plus I squared. Well, that's a negative I minus 1. Yeah? So I'm going to line it up. You've got a negative 1 minus I there. When you add those together, you'll have a negative 2 minus I. You got to multiply that times I, which will give you a negative 2I minus I squared, which will give you a negative 2I minus negative 1, so a plus 1. I'm going to write it as a 1 minus 2I. So that'll give you a 2 minus 2I. Multiply that times I. I warned you, this part is ugly. 2I minus 2I squared, which will become a positive 2I and then a plus 2. Okay, getting better. So this is a 2 plus 2I, which those 2's will cancel out. You'll be left with just a 2I. And then you multiply 2I times I. So I times 2I will give you a 2I squared, which is a negative 2. You better get a 0, right? They told us that it was 0. And so, yeah. All right, so I know that was ugly. It's going to be ugly when on the first imaginary one. All right, then we're going to do synthetic again, but this time it'll be super nice, and we're going to use the fact that we know that negative I is, if I is a 0 and you had real coefficients, all of these numbers in front were real numbers, and so negative I is also a 0. We're going to do that with this depressed equation. I'm using that guy. All right, so I'm not going to remember these numbers, but it was a 1 and then a 1 plus I and then negative 2 minus I, negative 2 minus I. I think the next one was a negative 2 minus 2I. Horrible memory with numbers. Nope, a positive 2. 2 minus 2I and then a 2I. 2 minus 2I and then a 2I. Okay, those are my coefficients. I'm plugging in a negative I now. And this one will be really nice. Like all of the i's will go away immediately. So you have a 1. 1 times negative I. Add those together, you're left with a 1. 1 times negative I. Uh-oh, I made a mistake somewhere. Did I write it wrong? Something's wrong, because I should not end up with any i's. Negative, okay, wait, come down here. Minus, shoot. 2I minus 2I squared plus 2. 2I plus 1. Something went wrong in a hobby. So that's a 2I. 2 minus, yeah. What's the matter? What did I do wrong? Negative I. Those should cancel right now, and they're not. Frickety fracketer. 1, negative I. 1, negative I. These should cancel. And I'm not finding my error. Oops. I'm not finding my error right away. But something's wrong. Negative 2I minus I squared. Yeah. 2 minus 2I times I is a 2I plus 2 plus 2I. Let's cancel 2I. Negative 2 whatever. Okay, I need to do this the other way because I'm not finding my error, and there's definitely an error. Is there? Or maybe is there another? Hold on. Let's see if there's another. 1, 2, 3. No. Okay, no. It should definitely be canceling out. Pooper scooper! I'm not finding my error. Okay, let's do this a different way then. This is 13 again, on page 381. Okay. If I know that I is a 0, then so is negative I. And so let's find the quadratic. The sum of these two guys would be I plus negative I, which is 0. Their product will be I times negative I, which is a negative I squared, which is a positive 1. It's a negative of a negative 1. So the quadratic from this, it'll be x squared minus the sum of the two guys times x plus the product. The quadratic will be x squared minus 0 times x plus 1, which means that it's an x squared plus 1. Right? All right, so now what you're going to do is do long division, because I messed up somewhere and I can't find my error, on this guy. But it should be pretty quick. It shouldn't be very ugly, I don't think. I'm not leaving myself much room, so it better be nice. Okay, so we got an x cubed, and then that'll be an x to the 5th. Plus x cubed, subtract, and this is like a 0 x to the 4th, so that means you'll have a minus x to the 4th minus 2x cubed. Oh crap, I did not leave myself enough room. Okay, this is a minus x squared, which will give you a negative x to the 4th minus x squared. Subtracting that, changing the signs on both of them. You know, this seems too hard. Let's move on, because this is taking too long already. I can do it, but like, why waste our time on something that is going to be too time consuming for the test anyway, so it's not going to be on there. Sorry, I should have stopped this a long time ago. All right, page 381, number 16. Okay, that one's a good one. So page 381, number 16, is, oh, you guys need that for your homework though, huh? All right, I'll go back and do it. Okay. Because was number, you tell me, was number 13 on your homework? I think it was. This is your homework, huh? Yep. Okay. All right. Okay, I'm doing number 16. Locate the real zeros between consecutive integers of x cubed minus 4x minus 6. So here's what I know. Well, they want them just between, which consecutive zeros, or which consecutive integers is there a 0. So I'm going to do repeated synthetic division. There's a 1 and a 0 and a negative 4 and then a negative 6. Cubed, squared, yeah, okay. Let's start with a 1. Bring down the 1. 1 plus 0 is 1. 1 plus negative 4 is negative 3. Negative 3 plus negative 6 is negative 9. So there's not a 0 there, because this last number is a negative, and so is this one. So you're still underneath the underneath the x-axis. So there's no 0 there. Go to 2, bring down the 1. 2 plus 0 is 2. 4 plus negative 4 is 0. 0 plus negative 6 is negative 6. All right, you're still negative, right? So there's still not a 0 there. Go to 3. 3 plus 0 is 3. 9 plus negative 4 is 5. 15 plus negative 6 is 9. 15 plus negative 6 is 9. Yes. Now, since you went from a negative to a positive, then the intermediate value theorem says there is a 0 between. Right? So in between here. So between 2 and 3, there is a 0. And 3 is an upper bound because it's positive. We're going positive, 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 positive. So upper bound. So you wouldn't try 4 or anything bigger than that. Let's go to the negatives and see if there's any zeros there. So we try negative 1. Bring down the 1. Negative 1 plus 0 is negative 1. Positive 1 plus negative 4 is a negative 3. Positive 3 plus a negative 6 is a negative 3. So you went negative to a negative, so there's no 0 between there. Negative 2, and it's also not a lower bound because you need them to alternate in sign. 1, negative 2 plus 0 is negative 2. 4 plus negative 4 is 0. 0 plus negative 6 is negative 6. Still no 0, but this is a lower bound because your signs went from positive to negative to 0. You can say is either positive or negative, whichever you need for the pattern, and then a negative. So negative 2 is a lower bound. Negative 2 is a lower bound, which means there aren't any more. Don't keep trying. 3 was the upper bound. So we'll say that too. 3 is the upper bound because they were all positive. And so we've got our bounds and we only found 1. And so between 2 and 3 is where those zeros would be. All right, what else? I can go back and do that stupid problem. It's giving me issues. It's going to drive me crazy if I don't fix it. But something that complicated is also not going to be on the test. So if you have other questions, how about, are you good on when they want you to solve for that k value, like the coefficient in the middle there? Things as linear factors. We did a partial fraction decomp. We did a solving radical ones. What else? Anything else? You're not typing, so I guess I'll go back and fix my stupid problem. Makes me so mad. Obviously, I have a sign wrong somewhere that I just didn't catch because it was close. All right, you guys keep looking to see if there's something else, and I'll fix this stupid problem. We were doing an x squared plus 1. This is again back to page 381, number 13. And we're going to divide x to the 5th minus x to the 4th minus x cubed plus x squared minus 2x plus 2. It's going to be an x cubed which will give you an x to the fifth, and then a plus x cubed. Subtract, subtract. These guys cancel. This is like a 0x to the fourth. I probably should have filled in the missing little x in there. That would have made more sense. Minus 2x cubed. Bring this down. And then we would have a negative x squared, which will give you a negative x to the fourth, and a minus x squared. Subtract it, changing all the signs. This is like a 0x cubed. So you'd have a negative 2x cubed plus 2x squared. Bring that down. That will be a negative 2x, which will give you a negative 2x cubed minus 2. Minus 2x. This is going to be like a 0x squared. Changing the signs. Those guys cancel. You'll have a 2x squared. Ooh, 0. Finally, something canceled there. So plus a 0x, and then bring down this 2. So a plus 2. And then it's a plus 2, which means it'll be a 2x squared plus 2. Subtract, subtract, and you have a remainder of 0. All right, so all of that, so now we have a cubic. Holy cow, that I need to solve for that. Yeah, so I would do synthetic on that one. So far we have I and negative I, and then we've reduced it down to this cubic so that it's x cubed minus x squared minus 2x plus 2 minus 2x plus 2. And we want to solve this guy. So I would try a 1, 1, negative 1, negative 2, and 2. Bring down the 1, 1, 0, 0. Nice. Finally, something works in my favor. Okay, so we have I is a 0, negative I is a 0, positive 1 is a 0, and then we have this guy, which is x squared minus 2 equals 0. So x squared equals 2, which means x is plus or minus the square root of 2. And so we've got rad 2 and negative rad 2. That's 5 answers total. And it was an x to the fifth, so you should have found 5. Okay. Makes me feel better that I at least did that. Sorry for, I don't know where my mistake was. I'll check it out afterwards or something. All right, page 382, number 17. Okie dokie. Page 382, number 17, wants you to graph x plus 8 over x minus 5 and determine any intercepts or asymptotes. All right, so nothing cancels here. So you've got a vertical asymptote at x equals 5 because that's what's in the denominator, what would make the denominator 0. You have a horizontal asymptote. Well, you look at the degree on top and it's a 1, and the degree on bottom is also a 1. So the degrees are the same. And so y equals the leading coefficients, or b will be your horizontal asymptote. And there's an invisible 1 over 1. And 1 over 1 is just 1. So y equals 1 is your horizontal asymptote. If you have a horizontal asymptote, you do not have a slant asymptote. It's one or the other. It's never both. What else are we going to ask you? We're going to ask you for x-intercepts. And that will be when y is 0. And like I told you before, the only thing that contributes to once you go 0 equals x plus 8 over x minus 5, if you multiply both sides by x minus 5, it goes away. So the only thing that contributes to an x-intercept, or your zeros, is the numerator. So we got x is equal to negative 8. And then your y-intercept is when x is 0, and you plug in a 0 into x, and you'll have an 8 over 0 minus 5. So that's a negative 8 over 5, which is like 1 point something. And then my graph will look like I've got x equals 5 as a vertical asymptote. I've got y equals 1 as a horizontal asymptote. And then an x-intercept of negative 8. Let's say that's negative 8. And a y-intercept of 0, and then that would be like a negative 1 point something. So like you're right about there. All right, here's the deal. There is something happening on each side of this vertical asymptote. Always, always, every single time. Something different will happen. Think of it as a wall, and even though we're in my classroom, right, Mr. Kearns is behind me, there's definitely something going on, much different in Mr. Kearns's class than in my class, because he teaches English, right? So that wall, make sure you check everything. So this guy is gonna, that was messy, but whatever, is gonna curve like this. This one, when you plug in points, just plug something in. Like, you'll see that this guy will end up curving like that, because that's just how all rational functions do. But if you don't like that, plug in a bunch of points, do an XY table, plugging in points, but definitely don't ignore to the right of this vertical asymptote, because something is definitely happening over there. I just graphed so many rational functions, I know what happens, but let's go with, how about when x is, can I come up with something friendly? 1, 2, oh, 3, no, I want that way, so 6, let's go 6. When x is 6, so just right after the 5, you'll have a 14 over 1. So that's how I know, like, when x is 6 right here, I'm way up here. And then 10, no, 10 won't be nice. Anyway, regardless, like, you can just plug something in. Like, this would be, what, 18 over 5, which is about, what, 3 point something. You'll get decimals. Anyway, just keep on plugging things in until you see enough to know what's happening. All right, that was page 382, number 17. What else you got for me? We still have lots more time. Well, not lots and lots, but enough time to be able to do like a problem or two still. What else? I feel like your quizzes were really good, so I don't feel like there was anything on there that really stood to me. No other questions? We can call it early. You've got synthetic substitution, dividing using synthetic division. You've got to find, you have to do that whole solve for k if something is a factor, where k is like going to be one of the coefficients on one of the variables. Tell me if you want to see one of those. Product of linear factors. Given the roots, find the polynomial, determining all zeros. All of the possible rational zeros, that's the P over Q's. Descartes' rule of signs. partial fractions, lower bound, upper bound, between consecutive integers, rational functions. Oh, I'm still not typing. You need to go from I give you information of the zeros and you graph it, and then also given the graph, you come up with the equation. We've done ones like that tonight. On the graphing ones, I've done a couple of the graphing ones. Types that you're going to see. How about this? And then I'll answer Chris's question. Let's say, let me make something up real quick. Comparing comparing 2x minus 8 over plus 4 minus 2 versus, let's call, I'll call this one f of x, and I'll call versus g of x is x squared plus 2x minus 8 over x plus 2. So I think this was the one that Chris had asked me before. Let me think of it. So let's compare the discontinuities, right? So you would want to factor the top, and this would be an x plus 4 times x minus 2 over x minus 2. Yeah. And then versus g of x would be an x plus 4 times x minus 2. It factors the same way because it was the same function up there, but this time there was an x plus 2 in the bottom. So let's compare the discontinuities here. On the first one, do you see that those factors cancel? And so this guy becomes a removable discontinuity, which remember is that hole, it's that open dot. It's a removable discontinuity at positive 2, and then you figure out the y value by what's left here. So if you plug a 2 in there, you'd have a 2 plus 4, so 6. Yeah. So you have the removable discontinuity at that 0.26, you'd have that open dot, versus this one, g of x, none of the factors canceled, right? And so this one is going to have a vertical asymptote because the factor didn't cancel at x equals negative 2. Point for the removable discontinuity, a line, so you need an equation for the vertical asymptote. So that's what happens with different discontinuities. If the factor cancels, it creates a hole or a removable discontinuity at that point. But when a factor does not cancel in the denominator and it stays there, then it creates a vertical asymptote. All right, I'm going to do one with upper and lower bounds. Okay. Like, you want me to do the one on the quiz? Do the one on the quiz. That was the quiz, right? My biggest fear is that I'll actually do a problem that's from the test. I'm sure you guys would love it, but it would be horrible for me. Okay, quiz 11. They want you to find for p of x equals x to the 4th plus 3x minus 13. They want you to find the upper and lower bounds. So for upper bound, you got to plug in positive numbers. And the fact that they want the least upper bound, they want the first positive number that shows up as an upper bound. So I'm going to start by plugging in a 1 and then go to 2 and all that. Your coefficients are a 1. You're missing the x cubed. You're missing the x squared. You got a 3 and then a negative 13. All right, so upper bound, you plug in positive numbers, and when you get all positives going across the row, then it's the upper bound. So let's start with 1. Bring down the 1, that's a 1, plus 0 is 1. 1 plus 0 is 1, 1 plus 3 is 4, but 4 plus negative 13 is negative. So not the upper bound. Try 2, bring down the 1, 2 plus 0 is 2, 4 plus 0 is 4, 2 plus 0, yes, 4 plus 0, yes. 4 times 2 will be 8, plus 3 will be 11. 11 times 2 is 22, minus 13 will give you 8. All of these guys were positive, which means that 2 is the upper bound. Well, it's an upper bound, but then it is the least upper bound because it's the first one that showed up. All right, then I'm going to do the same thing again. Redraw. How far do I have? No, I need to go to a new screen because otherwise I'll run out of room. For the lower bound, you're going to plug in negative numbers. So I'll do the same thing. My coefficients were a 1, a 0, a 0, a 3, and then a negative 13. Try negative 1 first. Bring down the 1. Negative 1 plus 0 is negative 1. Positive 1 plus 0 is 1. Negative 1 plus 3 is 2. Negative 2 plus negative 13 is a negative 15. So I don't know why I kept going when positive, negative, positive. This one, the 2 should have been negative if it was going to be a lower bound. So really I should have stopped, but whatever. Try negative 2. Bring down the 1. Negative 2 plus 0 is negative 2. Positive 4 plus 0 is 4. Negative 8 plus 3 is negative 5. And then a positive 10 times a negative 13 is a negative 3. Darn it. We went positive, negative, positive, negative, and then darn it, the very last one didn't work. Usually when that happens, it'll be the very next number. Like when you're that close, when they're all alternating and then it's just the last one that didn't work, then it's usually the next integer you plug in. But let's try it. Bring down the 1. Negative 3 plus 0 is negative 3. Positive 9 plus 0. Negative 27 plus 3. And then whatever that is, what is that, 72? 60. Positive 72 minus 13 is a positive number. Whatever 72, 59, I think, hopefully. I think it's positive, yeah. So we've got a positive, a negative, a positive, a negative, a positive. They're alternating in sign. And you had plugged in a negative, and so that means that negative 3 is a lower bound, and it is the greatest lower bound since it's the first negative number we plugged in that worked. So, okie dokie. Well, you're welcome. All right, now looks like it's time. So, good luck. We'll review more tomorrow. Your test isn't until Friday, so. All right.